Hey guys, today we are going to do lesson 9.3, which is going to be all about the Pythagorean theorem. Now the Pythagorean theorem has to do with triangles and specifically with right triangles. And so before we dive into the Pythagorean theorem, we are going to do a real quick review of triangles. Now, I'm going to go through this pretty quickly because I think a lot of this is review for you, but I just want to hit on a couple key points. All right, the first thing is that when we have a triangle, obviously in order to be a triangle, it has three sides and therefore three angles. And we know that the sum, meaning if you add up all the angle measurements inside any triangle, it always has to equal 180 degrees. And so with that fact, we can find missing angle measurements in triangles. So for example, in number 1, if we want to find what x is, well, we know that one angle is 48 degrees, and the other angle, this one is 90 degrees. That's called a right angle, and right angles are always 90 degrees, and we can use that little square thing there to show that it's a right angle. So if I want to figure out what x is, I would first add 90 plus 48, which is 138. And then because I know that all the angles have to add to 180, I could do 180 minus 38 to figure out the missing angle measurement. And so I know that x would be 42 degrees here. And I could do that for any triangle. We'll do just one more. Number 2, we could do 33 plus 27. So when I add those, I get 60. And so then to figure out x, I would do 180 minus 60, which means that x would be 120 degrees. Now, when we classify triangles, we can classify them based on their angle measurements or their side measurements. So when we talk about their angle measurements, again, we're looking for the angles inside the triangle. If all three are acute, and remember that acute means that the angle measurement is less than 90 degrees. If all three are acute, then we call it an acute triangle. If the triangle has one right angle, which remember a right angle is 90 degrees, in this case it's that one right there. If it has one right angle, it is called a right triangle. If it has one obtuse angle, and remember obtuse means more than 90 degrees, so in this case there's the obtuse angle, so it's called an obtuse triangle. And think about this, there can't be a triangle that has either two right angles or two obtuse angles, because if you think about it, in order to have two right angles like this, we've already used up all three sides and we don't have a closed shape. So it can't have two right angles or two obtuse angles, it can only have one. If all the angles are the same, which would have to be 60, because 60 times 3 is 180, then we call it an equal angular triangle. When we talk about side lengths, if all the sides are the same, we call it equilateral. If two sides are the same, we call it isosceles. And if none of the sides are the same, if they're all different, we call it a scalene triangle. So what I want you to do is actually turn the page, and at the top of the next page, you're going to see several different triangles. And you are going to read the directions and classify them based on either their angles or their sides. So go ahead and try that, and then press play again when you're ready to check your answers. All right, take just a minute and check your answers with mine. So in the first part, you're identifying them based on their angle measurements, and in the second part, based on their side lengths. And so again, we reviewed this real quick because it's a good review of triangles. And the other reason is, as we jump into the Pythagorean theorem here, it's important to note that the Pythagorean theorem only works for right triangles. And so you need to be able to identify what is a right triangle to know if the Pythagorean theorem would work or not. All right, so in the Pythagorean theorem, we're going to be talking about legs and hypotenuse, and so we need to identify what those are in a triangle. The hypotenuse is the side opposite the right angle, or sometimes instead of opposite, we'd say across from So here's the right angle. So the side across from it is called the hypotenuse. All right, and then the legs are the sides that form the right angle. And so a right triangle always has two legs because two sides have to form the right angle. So in this case, it would be this and this. Those are the two sides that come together to form the right angle, and so they're called the legs. All right, now why is this important? Well, because here's what the Pythagorean theorem says. For any right triangle, again, we talked about this, it has to be a right triangle, the sum, meaning addition, of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Now, maybe you've heard this before. The Pythagorean theorem is that a squared plus b squared equals c squared. And a and b there have to be the legs. It does not matter which leg is a and which leg is b because we're adding them. We know that in addition, the order doesn't matter. So it doesn't matter which leg is a and which leg is b, but the legs have to be a and b. And then C is always the hypotenuse. And so if we add the squares of the legs, that would equal the square of the hypotenuse. Now, we have to be careful. A lot of people think, well, then could it be that just A plus B equals C? And that does not work because, again, we'd have to take the square root of the entire side, and the square root of A squared plus B squared is different than just A plus B. Okay, so we need to be careful with that. We have to keep those squareds in there. The other thing that's important for you to note is that the Pythagorean theorem is something that we're going to be using quite a bit. There's a lot of applications of the Pythagorean theorem, which is why it's one of the more popular theorems, meaning there's a lot of different situations that we can use the Pythagorean theorem to help us solve. And we're going to dive into some of those different examples in the next week or so. The other thing is Pythagorean is kind of a weird name, but just so you know, it's named after the mathematician who developed this theorem. His name was Pythagoras. How would you like that as your name? But that's why it's called the Pythagorean theorem, because it's named after the mathematician that developed it. All right, so let's go ahead and turn the page and try to practice this a little bit. All right, so we're actually going to start with a word problem because the word problems here really aren't that much more difficult than when there's not a word problem. This says a building's access ramp, meaning the ramp you would use to get into the building, has a horizontal distance of 24 feet and a vertical distance of 2 feet. And then they've drawn that for you. And so it wants you to find the length of the ramp to the nearest. It says 1/10 of a foot. We're going to change that to 100th. Because we always solve to the nearest 100th, so that'll just be easier to be consistent. All right, so in our picture, I just drew in there where the right angle is. And so the first thing you need to identify is, are you trying to find a leg or the hypotenuse? Well, because you want the side length that is across from the right angle, it would be the hypotenuse, which therefore has to be C. So in the Pythagorean theorem, we have a squared plus b squared equals c squared. So I'm going to plug in 24 for A and 2 for B and try to solve for C squared. Now, remember, it does not matter which one is A and which one is B. Okay, that really doesn't matter at all because you're just adding them, so the order makes no difference. All right, so you definitely want to get out your calculators here. I'm going to type in 24 squared is 576. 2 squared I know is 4, so that gives me then c squared. I'm going to add those two, and I get 580 equals c squared. Now, I don't want c squared, I just want c, so here comes into play what we talked about in a couple lessons ago, where in order to undo the squared, we have to take the square root, and whatever we do to one side, we do to the other side. And so I'm going to take the square root of 580, and that would be 24.08 when I round to the nearest 100th. Here's the deal. 24.08 is close to the right answer, but we did have to round that, so it's not precise. So we are always going to find it rounded to the nearest 100th. But then we also want to find it in simplest form, like we practiced in the last lesson, because that way we can have a precise answer. Okay, so I have the square root of 580. And so remember, I'm going to start going through my perfect squares. So I'm going to divide it by 4. Ooh, 4 goes into it, but I want to make sure there's nothing bigger that goes into it. So I'm going to try 9. That doesn't work. I'm going to try 16. That doesn't work. I know 25 won't work. I'll try 36. That doesn't work. Notice how I'm just going through my list. 49 doesn't work. Okay, so I've kind of decided I think 4 is actually my biggest one. So I've got the square root of 4 times the square root of 145. And so the square root of 4 is 2. The square root of 145 is not a perfect square. So in simplest form, my answer would be 2 times the square root of 145. And so for all of our answers, we want to give it rounded to the nearest hundredth and in simplest form. All right, now the last part of this problem is, because it is a word problem, we do need to have a label with it. And I forgot that label here in my answer. So I'm going to go back and add it. It should be 24.08 feet, or 2 times the square root of 145 feet. So make sure if it's a word problem or if there's a label in your problem that you have a label in your answer. All right, let's try a couple more. On this one, it labeled for you A, B, and C, so that's going to make it a little easier for us to plug things in. So I have 10 squared plus 24 squared equals C squared. 10 squared I know is 100. 24 squared, either use your calculator or look back at the last problem. That's 576 equals C squared. Then I'm going to add those, and that's 676 equals C squared. But again, I don't want C squared. I want just C, so I have to take the square root. And I have to do that to both sides. Again, use your calculator to help you. And on this one, 676 is a perfect square. So that's it. That's your answer. That's simplest form because it's a perfect square. If it comes out as a perfect square, you just have one answer. It's when it's not a perfect square that you need to round it to the nearest hundredth and give it in simplest form. But this one is just C equals 26. There's no unit in my problem, so I don't need a unit in my answer. All right, why don't you pause the video right now and try number 2. When you feel ready to check your answer, press play again. All right, go ahead and check your answer with mine. This one also came out as a perfect square, so your answer is just C equals 39. The last thing I want to point out here is it's always good to go back and double check that your answer makes sense in the context of your problem. So again, I'm looking, and if this is 15 and this is 36, yeah, it makes sense that that could be 39. If I had gotten that C was 3, that wouldn't make sense. If I got that C was 300, that wouldn't make sense. So make sure it makes sense in the context of your picture or your problem. All right, we're going to skip 3 and 4 and move on to the next page. All right, so you'll notice what's different about this problem is that now we know C, but we don't know A. And they helped us out on this one. They filled in A, B, and C for us. So let's go ahead and start with our Pythagorean theorem again. For every problem, we use this same formula, A squared plus B squared equals C squared. Well, in this one, A we don't know. B is 10, so I'll plug that in, and C is 15. All right, well, let's start with squaring each thing. So I have A squared plus 100 equals 225. All right, now think, if I want to get A by itself, what do I need to move away from the A? And hopefully you notice that in this problem, I'm going to need to subtract 100 to work towards getting A by itself. And so then I get that A squared equals 125, but I don't want A squared, I want just A. So here's where, again, I need to take the square root, and whatever I do to one side, I have to do to the other side. Well, use your calculator. The square root of 125 is 11.18. We're going to round to the nearest hundredth because that's what we always do. And this one, unfortunately, is not a perfect square. So that's going to be one way that I'll write my answer. But I also need to write this in simplest form. So again, I'm looking for which perfect square is a factor of 125. And on this one, it might jump out to you that 25 is a factor, and that's awesome if it does. So this would, 125 is 25 times 5. So I can write that as the square root of 25 times the square root of 5. And so in simplest form, this would be 5 times the square root of 5. Again, you're doing just like we did the other day in our notes and lesson. All right, this one doesn't have a unit in the problem, so I don't need a unit in the answer. So my answer is that A equals 11.18 or A equals 5 times the square root of 5. I'm going to write it both ways in my answer. Let's try another one. Jump to number 1. Again, we're going to always round to the nearest hundredth if it doesn't come out to be a perfect square. All right, now as you look at number 1, they have labeled what is A for us, but not what is B and C. So does it really matter? Does it matter which one's B and which one's C? Yes, it matters a ton. If you mix that up, it's not going to work. So how do you know what's B and how do you know what's C? Well, remember C is the hypotenuse, which is the side that's across from the right angle. So in this problem, 25 needs to be C. And then remember B is one of the legs, and the legs are the sides that make up the right angle. And so B would have to be the side length that is 7. All right, so now that we've labeled that, we can go to my Pythagorean theorem and plug in B, which is 7, and C, which is 25. And so then I'm going to square each of those. So I have A squared plus 49 equals, again, use your calculator as you need, 625. Now I want to get A by itself. So my next step is going to be to subtract 49 from each side. So I get that A squared equals 576. But again, I don't want A squared, I just want A. So to undo that, I need to take the square root of both sides, and I get that A equals 24. And again, that one was a perfect square, which we always love when they come out as a perfect square because we just have to write our answer one way. There's no rounding needed because it comes out perfectly. So my answer is A equals 24. All right, why don't you pause the video right now, try number 2, and then press play when you're ready to check it. All right, go ahead and check your answer with mine. Just like we talked about in the last problem, make sure you make C the side that is across from the right angle. So 15 has to be what you plug in for C. And then remember the legs are the sides that make up the right angle, so that's why 9 has to be what you plug in for A, and that does make a difference. This one again came out to be a perfect square, and that's awesome. So we just have to say my answer is B equals 12. All right, again, we're going to skip 3 and 4, but you can do those if you feel like you need a little more practice, and we're going to go on to the next and final page. Okay, so the final thing we're going to look at in this lesson is called the converse of the Pythagorean theorem. So the Pythagorean theorem is an if-then statement. It says if a triangle is a right triangle, then a squared plus b squared equals c squared. The converse is when you reverse those two statements. So we're going to flip it and we're going to say if a squared plus b squared equals c squared, then we know that without even drawing it, the triangle is a right triangle. And this is going to be helpful to us as well. Some theorems you're allowed to flip and some you're not, so you always have to be careful. Let me give you a non-math example. If I said, if it is raining outside, then the ground is wet, that would be a true statement. But if I flip that and say, if the ground is wet, then it's raining, that's not necessarily true. So you've got to be careful. We can't always flip if-then statements, but in the example of the Pythagorean theorem, we can. So here's how we can use that to help us. If we don't have a picture, so we can't see the triangle, but we just have the side lengths, we can figure out if it's a right triangle or not by using the Pythagorean theorem. So if I know that A is 8, I'm going to write 8 squared and then I'm going to plug in 9 for b. And basically I'm doing a check step to see, does that equal 12 squared? If I get a true statement, I know it's a right triangle. If it's not a true statement, then it's not. So 8 squared here is 64, 9 squared is 81, 12 squared is 144. And then I'm going to add 64 and 81, that's 145. Ooh, close, but not quite. Remember to put a slash through that equal sign. 145 is not equal to 144. And so my conclusion is this is not a right triangle. And that's what you need to write as your answer. Don't just put no, make sure you write not a right triangle. All right, let's go on to the next one. In this problem, we'd have 7 squared plus 24 squared equals 25 squared. And again, we're checking to see, does this make a true statement? Well, 7 squared is 49. Then 24 squared is 576. 25 squared is 625. Then I'm doing 576 plus 49. And I do get 625. So I've got a true statement here, which is awesome. So my conclusion is that this one is yes, a right triangle. So in some ways, you're just kind of doing a check step with the information they gave you to see if it fits the Pythagorean theorem and creates a true statement or not. The last thing I want to point out to you is I believe in your homework, sometimes on the homework or assignments or things, it just lists the numbers like this. So it might say B 7, 24, 25 in a list like that. And you can just assume that it goes in order, that the first is A, the second is B, and the last is C. The other thing is maybe you've already caught on to this pattern, but C, the hypotenuse, is always the longest side. It has to be the longest side. And so if you have a list of numbers, C is always the biggest number, and then A and B, it doesn't matter which is which. So the two smaller numbers would always be your A and B. All right, hopefully that helps. And like I said, we're going to be using the Pythagorean theorem quite a bit here in the next couple days because it helps us solve all sorts of problems. Have a great day.